Welcome to The Explainer. Today, we're going to pull back the curtain on a critical process you've probably never even heard of, but it's one that keeps some of the world's most powerful machines up and running. It's called hot oil flushing.
So let's just jump right in with a question. Picture this, a massive, multi-million-dollar gas turbine, a true beast of engineering. What do you think is its biggest threat? What could bring that whole thing to a sudden, grinding halt?
You might think it's some huge explosion or a major system malfunction. But no, the real culprit is often something you can't even see. Tiny, microscopic particles that can trigger absolutely catastrophic failures. So why are these tiny little specks of dust such a huge problem? Well, to really get it, you've got to appreciate the sheer scale of the machines we're talking about here. These are the giants of the industrial world. We're not talking about your car engine here. We're talking about the absolute heart of major operations. Things like gas turbines, massive compressors, and incredibly powerful hydraulic units. These are precision-engineered titans where even the smallest imperfection can cause the whole system to fail. Okay, so now let's meet the bad guys in this story. And it's not just one single thing, but a whole crew of unwelcome guests that can be lurking deep inside these systems. They're called contaminants. You can think of the lubricating oil in these machines as their lifeblood, right? It circulates everywhere. Well, contaminants are basically poison in that bloodstream, clogging up the arteries and threatening the health of the entire machine. And they come in all sorts of nasty forms. You've got this sticky sludge from old oil, little bits of rust and scale from moisture, and even tiny metal shavings or pieces of welding slag left over from when the machine was first built. Every single one of them is like a tiny ticking time bomb. And this quote really hits the nail on the head. The cause is microscopic, but the effect, it's massive. A few tiny particles can completely seize a pump, destroy a critical bearing, and force an entire facility into an unplanned and unbelievably expensive shutdown.
All right, so you've got this dangerous, invisible enemy. How in the world do you fight it? Well, there's a solution, and it's basically like a power wash for the insides of these industrial giants.
And that brings us to the hero of our story, hot oil flushing. The idea sounds pretty straightforward, but the execution is some seriously cool engineering. You're pumping heated oil through the system, but, and this is the key part, at an insane velocity to literally blast all that accumulated gunk loose.
Now, you might think the hot part is the secret sauce, right? I mean, heating the oil definitely helps it flow better. But the real game changer here isn't the heat, it's the speed. The entire goal is to create this powerful, chaotic state called turbulent flow. So check this out. Under normal conditions, oil just kind of flows along, nice and smooth. That's called laminar flow. But the problem is, it's too gentle. All the heavy gunk just settles on the bottom of the pipes and stays there. But turbulent flow? Whoa, that's a different story. You're turning that gentle stream into a raging river that literally scrubs the inside of the pipes clean and drags all that nasty debris out with it. And this isn't just a matter of turn on the hose and hope for the best. It's a really precise four-step engineering process. First, experts assess the whole system to create a plan. Then, they get that hot, high-speed oil circulating. All the while, they're running it through powerful filters and constantly monitoring the cleanliness levels until finally, they can give it the all-clear and certify that the system is clean. And the end goal here isn't just to look clean. Nope, it's about hitting a very specific, measurable target. The process keeps going until the oil's purity meets these super strict international standards, known as ISO cleanliness codes. It's a scientific guarantee that the system is truly, deeply clean and safe to get back to work.
Okay, so the system is sparkling clean. So what? What's the payoff in the real world? Why go through all this trouble?
Oh, the benefits are huge. I mean, first off, you're massively cutting down the risk of those crazy expensive shutdowns we were talking about. The equipment itself lasts way longer. It runs more efficiently, it's safer, it can even improve the quality of whatever product is being made.
But let's be real. The number one reason to do this is money. Plain and simple. An unplanned shutdown can cost a company millions of dollars. Millions. So preventing even one single catastrophic failure by doing this kind of maintenance, well, it pays for itself many, many times over. It's proactive protection for a massive investment.
Let's just zoom out for a second, because this is about more than just one company's bottom line. There's a bigger picture here.
When it comes down to it, keeping these machines healthy isn't just about protecting an asset. It's about making sure the entire energy infrastructure that we all rely on every single day is stable and safe. Smooth-running machines mean a reliable power grid and a consistent energy supply for all of us.
And that really is the key takeaway. This invisible, highly technical maintenance work is the very foundation of smooth, predictable, and uninterrupted performance in an incredibly complex and vital industry. Purity equals reliability. It's that simple.
Kind of makes you wonder, doesn't it? What other invisible processes like this one are working behind the scenes, quietly keeping our modern world from grinding to a halt?